Recording has started.
So again, I labeled these equations A, B, and C so we can refer to them quickly. And this one's set up so there's actually two different variables that would be relatively easy to cancel out using the addition or elimination method. The y variables would not be hard. We could just change this into a positive 2 and this into a positive 2, and they would both cancel with the negative 2. The z variables wouldn't be bad. These two already cancel. We just have to change this one to a negative 2, and it would cancel out. So it's really a matter of choice on which variable we want to cancel out. I am going to choose to cancel z first. Just because I just kind of randomly chose it. So here's what I'm going to start off with. I'm going to start off with 2 times equation A. So 2 times 3x is 6x. 2 times y is 2y. 2 times negative z is a negative 2z. Equals 2 times 2 is 4. And I'm going to combine that with equation C, which is 4x plus y plus 2z, 7. So you can see why I used equation Z, because I have a negative 2z and a positive 2z. They are going to cancel out. They're going to be eliminated when we do our addition. Let's do our addition. 6x plus 4x is 10x. 2y plus y is 3y. Negative 2z and positive 2z cancel out, equals 4 plus 7 is 11. So this is my first of my two variable equation. Now the one equation I have not used yet is b, so that means I have to use b here. I'm going to go ahead and just combine b with c. Because I've got negative 2z and positive 2z already, it'll cancel out. Now it's important here, z is the variable I canceled out the first time. I have to make sure that I cancel out the same variable, in other words, z, again this second time, in the second step. So x plus 4x is 5x. Negative 2y plus positive 1y is a negative 1y, or negative y. I'm going to write it as negative 1. Negative 2z and positive 2z cancel out, 0z. And 6 plus 7 is 13. So here is my two variable system. Then x plus 3y equals 11. 5x minus 1y equals 13. Now, since these are both combinations of other equations, I'm going to relabel them equation D and F here. And what I'm going to do, I'm going to leave equation D as it is. But I'm going to take equation F and I'm going to multiply by 3. The reason for that, 3 times negative 1y will be a negative 3y, and that's going to make it cancel out. So 3 times f, well, 3 times 5x is 15x. 3 times negative 1y is negative 3y, equals 3 times 13 is 39. So now we'll add to eliminate our variable. 10x plus 15x is 25x. 3y plus negative 3y is gone. It's 0y. 11 plus 39 is 50. Now we solve for x. We're going to divide by 25. X equals 2. So I have x. I need to go back and find y, or one of the other variables. I go back to my two variable system here, substitute into one of those. I'm going to do the top one just because it's positive variables. So 10x becomes 10 times 2, because x was 2, plus 3y equals 11. 10 times 2 is 20, plus 3y equals 11. Now we'll start to solve. We'll subtract 20. So 3y equals 11 minus 20 is a negative 9. and we'll divide by 3. Y equals negative 9 divided by 3 is a negative 3. So y equals negative 3. Now we have to find z. We got to go back to one of the original equations. I'm going to go back to 4x plus y plus 2z equals 7. I just picked one of the three. This one is where z is positive, so it might be a little easier to solve. So I put 4x becomes 4 times 2, plus y is going to become a negative 3, plus 2z, 7. 4 times 2 is 8. Eight plus negative 3 is 5. So 5 plus 2z equals 7. Now I can subtract 5. 2z equals 2. I can divide by 2. Your z equals 1. So my solution to this system, x is 2, and y is negative 3, and z is 1. Not so bad. Well, what happens when we hit one like number 6? X plus 2y minus z equals 2. 3x plus 7y minus 5z, 6. X plus 2y equals 3. We can see in the third equation, I'll label them A, B, and C again. In equation C, there isn't a z variable there. Now, when we did substitution, that made the whole process easier for us because we could solve that equation for x and we just have 3 minus 2y. It's a little bit simpler expression to substitute in. If we're doing the addition or elimination method, we have to account for that variable. So what we have to do is put in a 0z there. So x plus 2y plus 0z equals 3. Now, there really isn't an obvious variable to cancel out here. X wouldn't be horrible to cancel out because I've got an x, a 3x, and another x. I can multiply equations A and C by negative 3 to make the x cancel out. But I'm going to save us a little bit of work. Since equation C only had 2 variables to begin with, I'm going to keep that as a 2-variable equation. So take back out that 0z. What that means is I need to cancel out z in the other 2 equations. I need to combine equations A and B in such a way that z also disappears. And here's the way I'm going to do that. I'm going to do negative 5 times equation A. So I've got negative 5 times x is negative 5x. Negative 5 times 2y is a negative 10y. Negative 5 times z is a positive 5z. And negative 5 times 2 is a negative 10. The other one, equation B, I'm going to leave exactly as it is. 3x plus 7y minus 5z equals 6. And you can see I've got a positive 5z and a negative 5z. They're going to cancel out. So let's combine them. Negative 5x and 3x make a negative 2x. Negative 10y and 7y is a negative 3y. 5z and negative 5z is 0z, so that cancels out. Negative 10 plus 6 is a negative 4. Now, all of those are negative. So what I'm going to do is I'm going to multiply that by a negative 1. Actually, you know what? It might be easier to leave it. Let's leave it. I'm just looking at equation C thinking, I have a positive 1 in x. Let's leave that as just a negative 2x minus 3y equals negative 4. So this is what I got when I combined equations A and B. I now have that 2-variable system. I'm going to multiply, since I have a negative 2x in bottom and a positive 1x in the top one, I'm going to multiply that top equation by 2. You get 2x plus 2 times 2y is 4y equals 2 times 3 is 6. And on bottom, negative 2x minus 3y equals negative 4. So the x's are going to be eliminated here when I add my columns. 2x plus negative 2x is 0x, so it's gone. 4y plus negative 3y is 1y, or just y. 6 and negative 4 make 2. So I got y equals 2. Let's go back. We're going to use this equation to find x. X plus 2 times 2 equals 3. 2 times 2 is 4. X plus 4 equals 3. If I subtract the 4 from both sides, x equals negative 1. Need to find z. Have to go back to one of the original equations. Obviously, I can't use the bottom equation because there isn't a z in that one. Let's just go up to the top equation. So we have negative 1 and 2. So x is negative 1 plus 2y is 2 times 2 minus z equals 2. That's just using this equation, putting in the values that we know for x and y. Nothing to do with the negative 1. 2 times 2 is 4. Negative 1 plus 4 is 3, so 3 minus z equals 2. Subtract 3, giving us negative z equals negative 1. We'll divide. This is really a negative 1z, so we divide by negative 1. We get z equals positive 1. So the ordered triple there, we have x is negative 1, when y is 2, and z is 1. Still seems like a lot of work, I realize, but it's it's not bad. You just got to be careful. Well, what if we have a system like the one we saw that was custom made for substitution? It looked like this. Realistically, it would be silly to solve this one with the addition method because it's set up to do substitution. This equation only has one variable in it. I can solve for z by just dividing by 3. Then I can put that in here for z and solve for x, and then put those into the top one to solve for y. This system is tailor-made to use substitution in. It would be silly to use any other method. Substitution is the easy way to go. But if we insist on using elimination, which I'm going to right now, we have to put in the 0y there and the 0x and 0y down here. That's a positive 3z, so I put plus in front of it. And now we can use elimination to solve this. Well, really, the only variable that I can eliminate here, I could use, well, the only thing I have, since I only have the only variable in equation C is z, the only thing I can eliminate is the z. My mind just, when I see that one, my mind's so hung up on substitution, it takes me a few minutes to force myself into the addition mode. So here's what we're going to do. I'm going to do 2 times equation A, which will be 6x plus 4y plus 2z equals 8. I just multiplied everything in there by 2. And equation B, 5x plus 0y minus 2z equals 2. So I didn't do anything to equation B, just rewrote it. I add those, 6x and 5x is 11x. 4y and 0y is 4y. Positive 2 and negative 2z cancels out, equals 10. So there's a two-variable equation. Now I'm going to do a similar thing for equation C. I'm going to use b. I'm going to use 3 times b, which is going to make that 3 times 5x is 15x. Well, 3 times 0y is still going to be 0y. 3 times negative 2z will be a negative 6z. And 3 times 2 is 6. Then I'm going to use 2 times equation C. Well, 2 times 0x and 2 times 0y, those are still just 0x and 0y. 2 times 3z is a positive 6z, and 2 times 12 is 24. So I go ahead and combine these equations. 15x plus 0x is 15x. Well, 0y plus 0y is still 0y. That's gone. Negative 6z plus 6z is 0z. That's gone. 6 plus 24 is 30. So there's my two-variable system with those two equations. And we do end up with one that is still just a single variable. So I'll divide by that 15, get x equals 2, and then work my way back through. I guess I have to go to this as my only choice here for a two-variable. So 11 times 2 plus 4y equals 10. 11 times 2 is 22 plus 4y equals 10. Subtract the 22. 4y equals negative 12. And we can divide by 3. Or divide by 4, sorry, to get negative 3. Y equals negative 3. Negative 12 divided by 4 is negative 3. Now I still need to find z. I have to go back to one of my original equations. Well, it's kind of silly because 3z equals 12, so I know z equals 4. So let's use the 5x minus 2z equals 2. And we'll put in the 2 for x. So 5 times 2 minus 2z equals 2. 5 times 2 is 10. Minus 2z equals. We'll subtract the 10. Negative 2z equals negative 8. And we divide by negative 2. Equals z equals 4. So we get x is 2, y is negative 3, z is 4. So we can still solve that system with the addition-elimination method. We just have to make sure we put in zeros for those missing variables. But like I said, that was a lot of extra work to solve that with addition, rather than just doing the substitution and getting it over with. If you see an equation that is easier to solve with one method than the other, just use that easier method. Okay, so let's do one more example here, and then we'll turn you on your way. So 2x plus y minus 3z let's see. It's 13. 3x plus 2y plus z equals 11. And let's do negative 4x minus 2y plus 6z equals negative 26. So we're going to label these equations A, B, and C again. And we're going to pick a variable to eliminate. Well, it sticks out to me that y is probably going to be the easy target here. I can combine equations B and C, the y disappears. Don't have to do a whole lot of adjustment to A to make it combine with C to disappear as well. So I'm going to do that right away. I'm just going to do B plus C. 3x plus negative 4x is a negative 1x. 2y plus negative 2y is 0y. It's gone. 7z plus 6, or 1z plus 6z is 7z. Equals 11 plus a negative 26 is a negative 15. There is one of our two variable equations. Next, I'm going to do 2 times equation A, which will be 4x plus 2y minus 6z equals 13. I'm going to combine that with equation C. Negative 4x minus 2y plus 6z. Oops, this should not be 13. I had to multiply that by 2. That would have been 26 there. Equals a negative 26. However, when I go to add these, something strange occurs. Negative 4x and negative 4x is 0x. That's gone. 2y and negative 2y is 0y. That cancels out. 6z and negative 6z cancels out. That's 0z. I have 0 on the left side. Now, at this point, there's only 2 options for the right side. Either the right side is 0, which in this case it is. 26 plus negative 26 is 0. What that means is that these 2 equations, A and C, were really the same equation. Equation C was really just a negative 2 times equation A. If you take equation A by negative 2, you get equation C. If the number over here is not a 0, if you get 0 equals a number that isn't 0, then what it's saying is these 2 lines are actually parallel. If that's the case, if you get 0 equals another number of some sort, then that is saying there is no solution. So these lines are parallel. Okay, with that, we had that worksheet from yesterday. I'd asked you to do it's the same one we used for substitution. I'd asked you to redo the odd-numbered question, or the even-numbered questions, I should say, using elimination or addition instead of substitution. So today I'm going to have you redo the other 4 questions using the addition-elimination method. Tomorrow, there will be a quiz on solving 3-variable systems. Actually, not tomorrow. For you guys, it'll be Monday. Sorry. You guys won't have class again until Monday. So that quiz is already posted out there if you want to work on it over the weekend. I know a few of you like to work ahead. It's just 3 questions on solving 3-variable systems. Remember, we can always double check our answer by going back to the system. That one didn't get a solution, but here we had 2, negative 3, 4. We can go back up here and put in 2, negative 3, and 4 and make sure we get this correct number. We just have to make sure we do it for all 3 equations, because it is very possible for that solution to make 1 or even 2 of the equations true, but not all 3. So make sure you test it in all 3 equations if you need to. So with that, we have about 19 minutes left, 18 minutes, I guess now. I'll give you that time to get started on homework. I'll be on the network here for a while. If you have, where'd my mouse go? There we are. If you have any questions, I'll be here to answer them. Otherwise, if you would like to